Hi guys, it's Miss Griffin. We're taking a look at Unit 6, Skill 6. It's the second to last one that you have in this unit, and I think that at this point you guys are doing fabulously, or at least that's my prediction, with Trig. We worked on word problems in the last skill. We're going to just build on those in this skill with multi-step word problems. So take a look at your essential question, jot it down real quick, pause the video if you need to do that. The question is, how do we complete multi-step word problems? Boom. So our first example, we have this flagpole at the top of a building. You can clearly see that in the picture. It's 300 feet from the base of the building. The angle of elevation to the top of the pole is 32 degrees. So remember, angle of elevation means to look out and up. So we look out and up to the top of the flagpole, and it's 32 degrees. However, the angle of elevation to the bottom of the flagpole is 30 degrees. So look out and up to the bottom of the flagpole, though, and it's only 30 degrees as the angle. Determine to the nearest foot the length of the flagpole. So in the end, we want this piece of information, the height or the length of the flagpole. Now that's a vertical height, so we're going to focus on vertical heights of other things, such as maybe the entire height, because I could make a right triangle out of that. So maybe we'll call this X. And maybe we want the height of the building because, again, I can make a second right triangle out of the height of the building, say Y. But now I know that the entire height from bottom to top, where's my laser? There it is. From bottom to top is X. I know that the building takes up part of that total height, which is Y. And I want this leftover height for the flagpole. So what we're going to do is, in the end, we're going to take the big value X and subtract away the small value Y. Now I know X is big because it's the taller of the two. That's what I represented as the tallest piece, Y being the smaller piece. So we got to do a little bit of work. Multi-step means there's more than one step. And so what we're going to do is separate and redraw the pictures. Separate. Oh my gosh, if you hear any noises, it's my cat. She's running around like a crazy woman. Well, crazy cat. Separate and redraw the pictures. And you want to do this such that you have right triangles, like I had outlined initially. So first we're going to find X. You could find Y first, it doesn't matter. I'm just choosing to find X because that's what I wrote down first. And that was the big triangle where we had X as the height. We have 300 feet as the base. And all the way up to the top of the flagpole, remember, was 32 degrees. I'm also going to set up how to solve for Y, so that way we have that picture drawn and you can kind of move ahead if you get done with finding X. So this one's a smaller triangle, same base of 300. This time the height is called Y. That's the height of the building that we're finding. And then the angle to the top of the building, or in other words, the bottom of the flagpole, was 30 degrees. So now we're going to come back to SOHCAHTOA like we've been using. Maybe you want to jot that down off to the side. Remember, Miss Wesley loves to use some old horse caught another horse taking oats away. Whatever helps you to remember it is fine. And you always want to stack your letters just like you see I did it in the fraction form, so that way you know that opposite goes over the hypotenuse when we're using sine, so on and so forth. So we're going to start the first problem over here on the left, find X. I'm going to circle my angle, and I'm going to label my sides. Remember, Wesley always tells you to go opposite first. We know that the right angle is here at the base of the building and the ground, and so this is my hypotenuse, and therefore this leftover piece of 300 is the adjacent. Adjacent, again, meaning next to. So I'm given the 300 for my adjacent, and I need the opposite being X. O and A force us to use TOA, or in other words, tangent. Tangent of something is equal to something over something, right? You guys are used to this basic setup, so this part should be a no-brainer for you. It's just setting up the initial pictures in order to solve for them. So angle goes inside the parentheses, opposite over adjacent, TOA, X over 300. Because we're solving for sides, we are going to put this over 1. And from here, of course, you're going to cross multiply. So we have X equals 300 times tangent of 32. So I want you to solve this, give it to me with, I don't know, 3 or 4 decimal places. Don't round yet. We have to round at the very, very end. But while you're solving this, I want you to pause the video because I also want you to solve for y. So you're going to finish solving x, and then you're going to solve for y. When you're done, I'll have all my work written here, and then we'll move on to what will be step 3 of this problem. So again, pause the video, show your work, do what you need to do to solve step 1 and step 2. Hit play when you're ready to see my work. Alright, so I found that x is equal to 187.4608. There might be more decimals. There likely is more decimals, or are more decimals, but I told you to just give it to me with 3 or 4. So that's fine. And then I did all of the same exact work over here for finding y. I still used tangent. I had opposite over adjacent. I cross multiplied, and I found y to be 173.2051. So if you have these numbers, you're good. If not, pause your video, go back and fix up your work. So now remember that this is not our final answer because we wanted the length of the flagpole, which was here and here, well, between here and here. And we know the entire height is 187, and then the height of the building was 173, so how do we find the height of the flagpole? Well, take the big number and subtract the small number, and then we have the height of the flagpole, and we need to round to the nearest foot. So step 3 is to find the height of, I'm not writing, height of flagpole. And so again, to do that, we're going to do x minus y, which means that we have 187.4608 minus 173.2051. Type it in your calculator, and again, round to the nearest foot. So we get 14.2557. Take my 4, look to the 2, and it tells me that this flagpole has a height of 14 feet. When you're ready, flip it over so that you can see the next example. Similar process, but we're not looking for vertical heights in the next one. Alright, so you can see that this problem looks a little goofy. It's not typed out like the last one was. This one actually came straight from a Common Core exam. It says, as shown in the diagram below, a ship is heading directly toward a lighthouse whose beacon is 125 feet above the sea level. So as we're reading, I'm just going to make sure that everything's labeled. We see the beacon is 125 feet above the sea level. At the first sighting, point A, the angle of elevation, so look out and up, to the from the ship to the light was 7 degrees. A short time later, at point D, the angle of elevation was 16 degrees. To the nearest foot, determine and state how far the ship traveled from point A to point D. So what we want in the end is this piece of information here. But again, we're not going to find that until we find maybe the entire distance as well as the distance from D to C. Because if we know the entire distance, say x, and we know the distance from D to C, then we can just do a little bit of subtraction. Big piece minus a small piece to find out AD. So you can clearly see, hopefully, that these are right triangles. ABC is a right triangle and DBC is a right triangle. They even put the box there for you, which is kind of nice. So first we're going to find x. And that's a huge, long triangle. X is the base this time. 125 is the height. And x uses triangle ABC, which has an angle of elevation of 7 degrees. We're also going to find y. So that's triangle DBC, where we have y as the base, 125 is the height still, and 16 degrees is the angle of elevation. And you can see me outlining this right now in blue. So again, I want you to pause your video. I want you to solve. Hit play when you're ready to see the work. My cat, I'm sorry. I don't want to walk through this with you because I think that you know how to solve these basic finding sides problems once the pictures are redrawn. So again, pause the video, solve both of them, and then when you're ready, do step 3, which is taking y away from x and rounding to the nearest foot. Hit play when you want to see the work for it. Okay, so I lied a little. I do want to just show you this part in case you forgot. The cross multiplying still happens here. We have x times tangent of 7 is equal to 125. Now our goal is to get x by itself, so we have to get rid of this tangent of 7 by division. So I'm eliminating tangent of 7 on the left side, but the right side gets typed into the calculator. Make sure that you use division in the calculator. I've noticed some people think that they're putting division in the calculator, but they just end up multiplying, and so you get a different answer. So when you do 125 divided by tangent of 7, and you are in degree mode, you should end up with 1018.0433. Okay, so now again, if you didn't get this, make sure you've typed in division in your calculator, like divided by, and then you should also be in degree mode. If you're not, then ask your teacher to help you out. Pause the video again, go back and find y, and then again follow through with step 3. Alright, so hopefully you found some success in solving. Your answers should have been for step 1, 1018.0433, as you just heard me say. And then for step 2, for finding y, we should have 435.9268. Step 3, to find the length of AD, remember that we are subtracting. X take away y, because x was my big piece, y was my smaller piece. So big minus small gives me 582.1165. When rounded is 582. So the distance he traveled was 582 feet. If you have any questions, just pause the video, call your teacher over so that they can explain it a little bit further to you in case you maybe didn't catch some of the work that I did in here. Or just pause the video so you can take a second to look at your work and compare it to mine. Alright, we've got one more problem. It's not a find sides problem, though. It's a find angles problem, which again came from another Common Core exam. So you guys are getting some really great practice right now with Common Core exam level questions. Flip it over when you're ready. Alright, so this came from an exam, as I just mentioned, number 34. It says, as modeled below, a movie is projected onto a large outdoor screen. Has anyone ever been to like Avon, the drive-in movies? That's kind of what this is trying to show you here. You have a projector that's projecting onto a large screen outdoors. Pretty cool. The bottom of the screen, the bottom of the 60-foot tall screen is 12 feet off the ground. So this screen is raised 12 feet from the ground and it's 60 feet tall. The projector sits on the ground at a horizontal distance of 75 feet from the screen. Determine and state to the nearest degree the measure of theta. Remember, this is just representing an angle. I'm not sure if Wesley called it x in skill 5.3 or if she called it theta. It's whatever you want to call it, but here in this case they actually did call it theta. What I'm saying is theta, theta. So we have to find that angle of projection, which means that we probably need to focus on some right triangles here. So I have my right angle here with the ground. When I'm looking at this, I could make a huge, gigantic right triangle where I have a full angle of elevation, maybe x. Let's actually draw that. Find x, where x is the angle, 75 is the base, and this entire height is 60 and 12 together. Don't confuse yourself, it's not just 60. We have 72 in total. Then I see that I have a smaller right triangle, and the angle of elevation, very, very skinny piece here, we can call y. So step 2 is to find y. Base again, 75, angle is y. The height this time is just the 12, because we're going to the bottom of the projection screen. In the end, we need to find theta, which right now, if I were to redraw this for you, we have x as this whole piece. There's a little line going through, we have y, and theta is the top part. So x represents the sum of theta and y. So to get just theta, it's kind of similar to the building problem or the ship problem. We have to take x minus y. Now, I want you to recognize that it's not always going to be x minus y. It just depends on how you label. If we had labeled this initial angle down here as y and this one as x, we would have done y minus x, because you always take the big and you subtract away the small. Okay, so step 1, find x. Step 2, find y. Step 3, subtract. And then we got theta. So we're still going to go through the same process. Circle your angle, label your sides, drag it across, and you have opposite. Here's your right angle, so across from that must be hypotenuse, and sitting next to the x is the adjacent. So here I have O and A, forcing me to use TOA. Not sure if you realized it, but tangent is used in a lot of real-world problems. It's not the only one used, but it's used often. So we have tangent of our angle in this case, which is x, is equal to opposite 72 over adjacent 75. Now in order to get x by itself, I'm not cross multiplying because it's stuck inside a parentheses, so I'm going to pull it out. And then I'm going to take tangent and move it to the other side. But when I do that, I have to apply the inverse. That's that little -1 thing that you've been using a lot recently. And then of course the side lengths get plugged in to the parentheses. So we're going to type this in our calculator. Tan inverse of 72 over 75. Make sure again that you are still in degree mode. And you get 43.8309 if you were to round to 4 decimals. Now you don't want to round to the nearest degree or nearest tenth of degree just yet, because if you round too early, your answer is going to be off. You can chop it off though after 4 decimals, you'll be okay. So now we're going to find y, same process, same idea. So I want you to actually pause the video and then hit play when you're ready to see my work. Alright, so for y I found 9.0903, x again was 43.8309, and third step is to find theta, which we said was x minus y. So 43.8309 take away 9.0903, type that in your calculator. You should have something like 34.7 blah, 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 blah. And nearest tenth. Tenth is the first decimal. Look to the right. That 4 tells us to keep the 7. So final answer should be theta equals 34.7 degrees. Yay, you just survived your multi-step word problems with Trig. Hopefully they weren't too bad. Again, it's just drawing the picture, figuring out what it is that you're solving for. If you need a horizontal length, then you should look at the other horizontal lengths. If you need a vertical length, look at the other vertical lengths. If you need angles, then look at the other angles. You know, you just have to separate and redraw your pictures in order to make it a little bit easier on yourself, because you guys are fabulous at solving for angles or solving for sides in and of itself. And then we just got to kind of put them together, do it a couple times, and then find the difference. Okay, enough blabbering. Get to work. Try those practice problems before you take your CFU. Let your teacher know if you have any questions. Bye, guys.